Hello everyone, my name is Rishi. Today I'll be walking through my implementation of data export system utilizing data change capture or CDC. So for this project, I used a pure JavaScript Node.js backend with Express. For the database, I used PostgreSQL, and the entire application is containerized using Docker and Docker Compose. So the problem, was when dealing with massive databases, exporting all data at once is slow, memory intensive, and puts heavy load on production databases. Further, consumers of this data only want to know what changed since their last export, rather than downloading everything from scratch every time. So so the real world use case of this was, this is heavily used in the real world for data warehousing, like syncing a Postgres DB to Snowflake, search indexing, which is similar to syncing to Elasticsearch, or just letting external B2B partners download nightly reports of their customer data. So now let us see how it works. So the system is divided into two layers. One is API layer and the backend processing layer. When a client requests an export, the API immediately returns a 202 accept status with a job ID. This prevents sorry yeah this prevents HTTP timeouts. So in the background, the server connects to the Postgres and uses offset pagination to fetch data in chunks of 10,000 rows. By writing these chunks sequentially, it keeps memory usage completely flat and can process uh, 1 million rows in about 2 seconds. So it streams this data directly into CSV files. So to handle the incremental and delta exports, I implemented a watermarks table. It exports the exact updated at timestamp of the last record a specific consumer successfully downloaded. The next time when they ask for data, we only query for records updated after this timestamp. So now let us go through with our project. So this project is structured efficiently by using this. Here in the SRC folder, you can see the two major folders: routes and services. So the routes handles the API endpoints, whereas the services handles the heavy lifting, and everything is tied with together in app.js and server.js. So here you can see the docker hyphen compose .yml file, and here is the init .sql file. So uh, I was facing a small issue with this from 2 days. So I started fixing it with the DB and the Docker compose file, and then I have and then I was getting the data. So yeah, sorry. Yeah, so here you can see the Docker setup, and the init SQL script is crucial as it automatically seeds the data with over 100,000 records, including simulating soft deleted records to mimic a real production environment. So in the exports.js, here are the API endpoints. Notice how we can capture the X consumer ID header. When a user hits export slash delta, we generate a job ID, since the response, and then triggers. Uh, yeah. So what happens here is the export service dot run delta export floating in the background, and then in the services you can see the export service.js. So in this is the core of the application. The execute export function dynamically builds SQL queries based on the requested export type. For delta exports, it calculates an operation column on the fly using an SQL case statement to mark if a record was an insert or update or delete. So the hardest part and challenges what I have faced is, the most challenging part of this task was handling memory efficiency and fast querying without duplicate processing. Initially, fetching 100,000 rows at a time might crash a Node.js process. So this I have solved this by implementing chunked pagination utilizing limit and offset in the execute export while loop. We fetch 10,000 rows at a time, order by updated at an ID. We build the CSV chunks in memory and use synchronized file appending directly to the file system. Memory stays constant, and the whole 10,000 k rows finishes in less than 2 to 3 seconds. And then another challenge was the race conditions or failed jobs. I solved this by wrapping the watermark update in a Postgres transaction, like with begin and commit and etc. So if file streams fails, the watermark isn't updated. So we use an upset on conflict do update. So this to ensure the watermark is safely updated only when the export succeeded. So here, currently, the background jobs are run inside the express process. If the server crashes, the job is lost. A massive improvement would be using a message broker like RabbitMQ or Redis with BullMQ to handle jobs queues and retries and worker scaling. So right now we are doing a polling approach based on the updated at column. True. Uh, True change data capture often reads directly from the database right ahead log using tools like Debian or Wall to JSON in PostgreSQL. This captures hard deletes, which we currently handle via soft deletes and is much faster. So overall, this project was a fantastic deep dive in streaming large datasets, stateful consumer tracking, and building robust non-blocking APIs. So let me demonstrate this project. So let's spin up the environment from scratch, which will also automatically seed the 10,000 100,000 records. So first thing what we need to do is we need to containerize this project. Yeah. So now I'm currently building the Docker file, and I'm running it in the server, Docker server. So yeah. So now now the Docker server has been started. Now let us open the Postman. Yeah. So I have opened the yeah. So in this already I have written the endpoints while testing. So here you can see here I have actually made a change while working with this. So here you can use this health endpoint to check the whether the server is running or not. So here you can see the status okay and with this timestamp. So that which says the server is running properly as expected. So now let us hit. So now let us hit the exports. So this would export the entire data, entire thing. So for that, let me wait. I'll remove this. So you can see here I have written the consumer ID, ex consumer ID with the test name as test underscore user one. So now let me hit this. Okay. Oh yeah. So sorry, I forgot to change the port number, right? So yeah. So you can see here the job ID. I have got a job ID. So now let us copy it for a moment, and then let's uh, so here meanwhile let us test it whether the Docker file was created in a proper way or not. So for that, we need to use the command like first of all we need to use Docker ps to go get the application name. I mean the name of the container. So here you can see the export system with data change data capture hyphen CDC hyphen app hyphen one. So with this, we need to get the logs, like Docker logs container name exports exports hyphen system hyphen with hyphen change hyphen data change capture hyphen CDC hyphen hyphen one. Okay, did I make any mistake? Okay, sorry. I have written like exports, right? Yeah. Here you can see the export job completed, right? So here the export job started, and you can see a message like export job completed. So that means it is showing like the export job has been started, and the export job also has been completed in the log files. So we have verified that we have verified like how many that the export has been completed successfully. So now let us check the watermark also. So yeah, let us go into the watermark and perform this too. For this, again, I need to use the same X consumer ID which I have given as test underscore user one. And wait a second, I'll just change the port number to. Now let me run this. Let me hit this. So yeah, you can see here, right, the consumer ID test underscore one and the last export date. So here the last export time was been recorded here. So what happened finally, because the job completed successfully, the system automatically saves the watermark timestamp. If we are if we fire slash exports slash incremental job right now, it will only extract records newer than this exact timestamp. So currently we didn't have added any of the data, right? So if we use the endpoint with slash incremental, the new records will be the newer records only will be exported. But since we didn't added any new data, it will not extract the newer records. Yeah. So thank you. This is my project. Thank you.